Hey everybody, it's Crist again, the Mad Scientist. I wanted to talk to you guys a little bit about a couple of things that we need to know when we're specifying a bunch of stuff, particularly pumps, but it also has an impact on filtration sometimes, but primarily for pumping, and that's a term of specific gravity. Basically every element has some kind of an atomic weight. We use in specific gravity for measuring, we use water as the common denominator. So water basically has a specific gravity of 1, relative number that was formulated, and other things which we actually can find right here in our Harrington Engineering Guide. And this is a great reference tool for a lot of information that will come up from time to time, and you'll be scratching your head, where do I get that? But I wanted to talk about specific gravity in terms of a couple of things. Stuff that we've got to move. Say I've got to pump water versus pump sulfuric acid, what specific gravity means there. But I thought it'd be interesting just to talk about materials for a minute. There's two things that look pretty much the same. You know, got two pieces of 1/4 inch here, about the same size as this piece of 1/2 inch. Well, what are these? Well, this happens to be 1/2 inch natural polypropylene. And we stock it in the branches. Here at Crist Group, we make tanks and parts and different things. Moreover, we use a whole lot of PFA, polyfluorinated alkoxy, or Teflon. This is the melt processable Teflon, and this is a lot heavier than this. Yet, when you compare these two things, they should weigh about the same. If I put this on this little gram scale, give or take, let's call 600 grams of weight, or about 0.4 pounds. If I put the same amount of PFA on this scale, start back at 0 again, this is about 0.10 pounds or 300 grams. So give you an idea of how much more this weighs than this. It's interesting too with specific gravity. If I take this and drop it in this bucket of water right here, it sinks like a rock right to the bottom of the bucket. If I take this piece of polypro, by the way, polypropylene, very first column in this chart is, guess what? Specific gravity. It says in here that specific gravity of steel is 7.86. That means that obviously that's going to sink in water. But polypropylene, interestingly enough, has a specific gravity of, if I can find it, 0.905. So it says it's about 1/10 less than water. If I put this piece of material in this tub, look at that, it floats right at the surface. Basically the top edge right surface, but this essentially will not sink because it has a lower specific gravity than water. Whereas PFA has a much higher specific gravity. That number, just by comparison, I said what, 905 for polypro. For PFA, it's 2.2. So more than twice the weight of polypro. PVC is a little heavier. PVC sinks because it's 1.2 or 3. I don't remember the number. We're not going to spend time on that. So let's talk about two terms. You'll hear viscosity and you'll hear specific gravity. What's the difference? Well, specific gravity is what we just talked about, weight. How much does something weigh based on a comparable size of something? Viscosity is the difference between pancake batter and water, or peanut butter, or liquid eggs, things of that nature that are thicker, may have a very, and some of that may have a very low specific gravity, but it's real thick and gooey. So those are things that you have to take into consideration when you're sizing a pump, for instance, or if you're trying to push a bunch of peanut butter through a piping system to a a jar canning line, tomato paste versus water, whatever. Those are things that in viscosity you got to take consideration of, as well as specific gravity, how much they weigh. Reason this is important in our business, obviously, we are corrosion control experts. We sell to chemical processing applications. A real typical one that I think of is sulfuric acid. And you can have sulfuric acid from 1% in water for some applications, or you could be transporting 98% sulfuric acid, which is pretty much close to full concentration. And it's interesting, now in the old engineering handbook, which is no longer available, but I still hold on to mine, because we've got a chemical resistance chart guide. These aren't always accurate, but they're a good guide to compare materials. If I look up sulfuric acid in here, we already know water is 1.0. And I'm going to look up sulfuric, and there it is. And at 98%, its specific gravity is 1.84, so almost twice what water is. So somebody wants a pump, and let's just say for grins and giggles that this pump's capable of 60 gallons per minute. Well, it's still capable of 60 gallons per minute whether it's water or whether it's sulfuric acid. But if I'm pumping sulfuric acid, then this motor's got to be higher horsepower because it takes more force. I need an Arnold Schwarzenegger motor for sulfuric acid, where I need just a plain old motor for a guy like me if I'm pumping water. So anyway, that's what I wanted to cover today about specific gravity primarily and how it compares to viscosity.